Hi, good evening, everyone. Welcome back to transportation modeling. So how is the quiz? Easy, right? Yeah, the answer is there, so you just need to do it again. Okay. Repeatedly until at the appropriate time. Okay. Today we will discuss about the agenda a while ago I showed. Okay. Today we'll discuss this is the quiz done. Okay, and we will discuss about policy analysis first part, and then we will do a simple IFN workshop. Okay, and then there's an assignment based on this today, and due to in 2 weeks. Okay, but next week you have the assignment about traffic animation that is from last week, right? So 2 weeks. Oh, okay. Someone chat me a while ago. Joven, what do you want to say? Sample of homework. Okay, sample of homework from last week. At least 2 vehicles. So if you use the 2 vehicles and you do exactly according to the slide. Okay, in the slide, let me open the slide. Car following building. Okay, and let me share slide with you. This is from last week. Okay. Can you see? All right, so this is we have the recording also, the video from our discussion last week. Okay. And if you look at that, okay, this is the formula. Okay, and if you look at this here, this is the answer, right? So this is suppose you are doing. Okay, this is the answer. And then if you go up there in the spreadsheet, some formula, this is what you need to do. Can you see?
Oh, okay, so that's the nonlinear already, sir, this spreadsheet.
Oh,
Not the with the there's the next slide, sir, which gives we
this,
will assume the
this,
alpha, that
yeah, this one is no. This is the linear. The first one, only two vehicles. This is exactly the practice here, right? So first you do the practice of 2 vehicles. Okay, so once you have this and it works, okay, and then try to change the behavior, oscillation, and so on. Okay, from there you can just change the formula. This one. So this is, if you look at, compare this formula with the earlier formula. Where is the earlier formula? This one, right? So this one. So the earlier formula, you see here, this is, what is this? This is acceleration, with 2 dot mean acceleration, with 1 dot mean velocity, yeah? Can you see that? 2 dot, that means acceleration. Okay, 1 dot mean velocity. Yeah? This is the n mean current time, n plus 1 mean 1 row after. Okay, n in here is a row. So that means this is the leading vehicles. Okay, and this is the next vehicles. Okay, so the velocity of the next vehicles, okay, with certain gaps here, it depends on, Okay, the acceleration depends on velocity. Can you see that? Okay. So acceleration is a function of velocity. So if you look at this, the same thing. Here, acceleration is also okay. Depends on velocity. Yeah. So a while ago, this one is 1/t, right? So the only difference is now instead of 1/t, I just name it lambda. Okay. Now that lambda, it depends on several parameters, yeah, alpha, m, and l. Okay. So in that case, m, alpha, m, and l is up to you to decide first time. Okay. So if you don't know anything, you just put 1, 1, 1. Okay. And then what will happen? What is this? With one dot, that means velocity, right? Without dot, that means the position. Okay. T is the time. So that means if xn minus xn plus 1, that means the position of the leading vehicles, and this is the position of the following vehicles. Is this clear? Compare this one. Okay, this is the formula is exactly the same. It did not change at all. Yeah. So the only thing is changed is the parameter here. Yeah. A while ago in this spreadsheet, okay, this is constant. Here T is constant. Can you see that? Now you need to add one more columns to represent this T. Okay, instead of constant, now you make it into a formula, this one, which depend on 3 parameters. Is this clear or you need more explanation? Okay, so the formula is still the same. Okay, acceleration depends on the relative speed, right? That one. So, but the parameter a while ago was constant. Okay? Now, if in the assignment you need to make it non-linear, yeah. So that's when you add one more columns just to change the parameter t. Now change become dynamically change over time. Okay, is that clear? Any question? Give me feedback if you still have any doubt. Okay, so okay then. So in that case, let's go to so with that, okay, curve theory, we can enter the next topic, yeah, in model 1252. So we have okay, let me open the model for you. Okay. So this is our model. So everything off. Right. So you set the recitation here. Okay. And then these are the reference. Okay. Cost syllabus is here. Okay. There is example of the traffic animation is in here. Right. So you can just open it. Yeah. This is what you're supposed to make. Huh? And you can use ChatGPT or any AI to make this. Okay. Based on the Tarfollow theory. Okay. Next, please resubmit the project group names because now you have 12. Okay. And this is what we discussed 2 weeks ago and last week. Okay, so the lecture is in here. Okay, and this is also the assignment, right? So this is the lecture last week, and this is what we will discuss today. Okay, this 1, 2, and this is the assignment. Now go here. Okay, you will have Excel add-ins. Can you download this? Do you have Excel in your computer? So this is an add-ins I made. Okay, that we can practice. Now, if you are familiar with Python, you can also download from IFN Transport. So if you go here, I put new tabs. You will go to GitHub. Okay, so then you just go here, download zip. Okay, can you see? And then unzip it. Okay, and then you download Python. Okay, for example, in here, I'll give you an example. Let me share with you the whole screen. Then one. Okay. So after I download Anaconda, for example, I will have this program called Spider. And this is the old one, old version. Can you see that? Okay. And now if I download and then I unzip it, okay, there is a code named main. Then when you run this, okay, there you will see something like this. So IFN Transport is a very simple program. Okay, so first you can download the OSM. Okay, there. So you can get the city names to get the boundary, or you can set by yourself. Okay, or you can go to OSM website. Okay. So if you go to OSM website, so you will have something like this, right? And then if you go to export, you will have this one, top, bottom, left, and right. This is the one that we copy. Okay, into this IFN transport, yeah, top, left, bottom, and right. Okay, and then you can select which road type. Okay, and then when you can download the map, okay, you just click this button. Yeah, so and you can display the network. Yeah, this is the example. You can display the network. And then you can zoom. Say you can drag here, and then you can zoom in more detail and more detail. Huh? Is it clear? Okay, and of course you can come back. Okay, the previous zoom or go home. Okay. And aside from that, you can define the scenario, very simple scenario here. Okay, so for that you create when you download the network, you're supposed to create a node and link. After that, you need to create a scenario file. Okay, and then you define and save scenario, and then you run. That's it. Okay. Now, if you don't like to download, it's not showing. Not showing. But I show entire screen. Okay, I will show entire screen. This one. Can you see? Okay, so you can go to OpenStreetMap, and then you say this is in around UP campus, right? And then you can, when you change this, that coordinate will change. Huh? You can also zoom in and zoom out. Okay, this is OpenStreetMap, similar to Google Map, but Google Map you need to pay. Okay, this one is based on donation, so it's free. Okay, so you can decide your own project area where you want to get. Okay, for example, I want to get it from here. And every time you zoom in, zoom out, pan, this coordinate will change. Is it okay? Then now you can also, aside from the GitHub, okay, so if you go to GitHub, you will get this. Yeah, go to GitHub and then you just download the zip file and unzip it. Okay, and then you will have you can read all this. This is how you install. Okay, this is how you run. Okay, you will get this kind of windows. Okay, this is what you will put there from OSM. Okay, you will have two names, node and links. Okay, and then you can display the network. Okay, so if you download directly, you will get this kind of map, which is quite complicated. But if you use IFN transport, you will get this kind of table that you can open in Excel, okay, or in GIS. Okay, and then these are the name convention. Okay, so the node must contain this one, the link must contain this one. Yeah? And then you can start to display the network, okay, and then you can zoom in and so on, depends on where you want to zoom in. Yeah, and then you can define the scenario. Okay, and this is how you define the scenario. So you need to know the scenario file must be end with SCN, and then the link file, node file, and so on. Okay, and this the link file supposed to contain in this order. Okay, and then the node file supposed to have this in this order, something like this. Okay, and then you can calibrate, and you can also calibrate based on real world, and then you just run. Okay, and then you can get certain optimization in the scaling. Okay, okay, that's all, I guess. This is how you will define the scenario file. So look at the example. There's also wiki there on the top. Oh, yeah. Okay, so I have transfer wiki. You can now also get more detail. Okay. Now, if you don't like to use Python, okay, if you don't like to use Python, you can just go to this website. Okay, so in this one web page. Okay, so if you right click here and open this, so you go to online. This is simpler but limited. Yeah. So using Python, the limit is your hardware. Meaning if your project is very big, you need to use Python. Yeah. And if your project is up to just 2,000, 1,000 something nodes and links, you can use this one. Yeah. Okay. And if your project is rather small, just like 10, 20 nodes, so you can use just for learning, you can use Excel. So, okay. So in here, the same like a while ago. So all you need to do is put the bounding box, okay, from OSM website. Right click here. So okay, and look at this level. Yeah, can you see? This is the bounding box is on the level. If you zoom in, it becomes level 15. Okay, so I'm suggesting here, okay, your zoom the map close enough, level 15 to 19, okay, for using this IFN transport online. Okay, and then after you zoom in, okay, you can check what is the root type that you want to download. Okay, if you want, also you can save the setting so that you can load back later on. Okay, and then you can also impute the settings here. The OSM does not give you the capacity or maximum speed. So in that case, you need to impute. Okay, so this is the default value that I use to impute. So if you don't like that, you can just change this. And this is a simulation of the imputation. For example, the number of lane is 2, road width is 5. Okay, this is one way. Then capacity is supposed to be this. If you don't like, you can just change this one. For example, now I changed it to 1/8. Okay, then you can see this one become 3/6. Okay. So this is the one that we use. So after that, you can also save the settings to JSON file and load it back if you want. Okay, and then this one is to download the map. Okay, so I suggest if you want to download, so you check this one, the clean to the largest strongly connected component. Okay, this one is automatically clean your data to be strongly connected. Okay. Once you input this data, you will get the network, something like this. Okay. So in this network, you can define the zoom level, the scaling. Okay. So the larger, for example, you cannot see, but you need to zoom in more detail. So depending on the level of your map zoom level, you can set this one. Okay, and then you can check, okay, in terms of color code, in terms of in here we have capacity, distance, and maximum speed, because this is still the data. Okay, and from there you can also find the node, find the links, and find any path, okay, or find shortest path, and find all paths and so on. Okay, and okay, this one is the distance. So this is the link number, and this is the distance. Okay, link number and distance. So where it is, that is in the network. Okay, so here, okay, so this is the node matrix, which is node ID, and then the X coordinate and Y coordinate. Okay, and these are the link matrix. Okay, link number, start node, which is the ID, and then end node, that again the node ID, and then link capacity, okay, and then link distance and maximum speed. So in here, maximum speed is 60 km/h. Okay. Once you download from OSM, you can save, okay, save the node matrix and upload it here, okay, or you can clean the whole things. Okay. You want to check the size, you will see that this is the size of 24.5T and so on. So yeah, and you check whether this is the most important test. Okay, after that you test whether it is strongly connected or not. Yeah? So if the network is strongly connected, then you can proceed. Yeah, if the network not yet strongly connected, so I suggest you clean up first. Now, so this is one of the way to clean. One is to clean to maximum strongly connected component. Okay, or you can add cloud node and dummy links. Okay. So the explanation is all in here. So I hope you can read by yourself. Okay. So once you have all of this link and node data, okay, so you can see there. Oh, the next step is just to use the model. Okay. So this is the example that we have. Let's start with very simple example. Let's say I have just a rectangle, right? So if you have a rectangle, of course, rectangle have 4 nodes, right? 1, 2, 3, 4. Okay, and these are the links that we set. These are the example. So there, this is the simple example that I have. Can you see? Rectangle. Okay, so 1, 2, 3, 4 is the rectangle. Say another example, I have a triangle. Okay, so of course I have one ABC. Okay, the node can be any number or ABC. Okay? And then this one also, the link ID start node and node. Again, I have here. See, this is the simple example. Is that okay? Start with simple first, and then you can make it more and more complex. Say triangle and square. Okay, and this one only have 5 nodes and the links, right? And then so I will have something like this. Okay, then you test first. This is strongly connected on my own. The network is strongly connected. Then you are ready to go to the next one. Yeah. So in here, you can choose any model. Okay, in here, of course, the default is ideal flow network, but you can also use all or nothing capacity restraint that we will discuss in the next few weeks. Okay, so and then you can also set the data, the constraint of the data. So whether you have the real world data or you have OD, origin destination flow, or you don't have any data, then you can assume something here. So for example, you can set the maximum congestion to be 0.9. Okay. And then you can choose what travel time model that you use. You already learned grid shield, right? So we can use grid shield in here. And these are the formula that you have from the slide last time. And then you can define your capacity in this network. Okay, here the capacity, link capacity is 1, 2, 3, 4. So the number 4 here is the capacity. In here I use lane. Okay, instead of real world capacity, I just use lane. So the capacity I can use in the lane, road width, or PCU per hour. Yeah. So in this case, I use lane. So here you can choose PCU per hour, number of lane, or road width. Okay. So if you use lane, then you need to decide what is the per lane, what is the capacity. Yeah. So in this case, I just said 1,800. Okay. You can set any number based on the highway capacity manual of your country. Okay, and then you can set this one. I use just simple proportional, otherwise become very complex model like that. Yeah. So simple proportional, the formula is like this, just proportion. If you use power exponent, you will use this kind of model. Okay, if you use GIS, you can also click here. Okay, and you can convert to shape file or QGIS or okay. Yeah. So that you can use that. Okay. This is just for legacy purposes that before we use this and transport the older version. Okay. Once you have this set, okay, say I use traffic flow, traffic assignment is using ideal flow network, maximum congestion level 0.9. And then all you need to do is just click calculate, you see. Okay, so then in the end, nothing, the field is still empty. So when you click calculate, you see you will get the result. Yeah. So this is the total flow. Okay, you can get all the statistics of the network. Okay, and this is the report. Okay, for each link you can see. This is for each link you can see the maximum speed, flow, capacity, and so on. Okay, and then you can also export it to Excel. Yeah, say there when you click to Excel. Okay, I hope you can see the Excel file. Of course, this is from the internet, so you'll see like this. So you can enable editing later. Okay, this is exactly the same as in the web. Okay, the network performance summary, and then this is summary for the network, and then for each link. Okay. Okay, so up to here, is there any question? So today you will practice, okay, with the workshop. So let's go to the model again. Go to the transport policy analysis 1. Can you? In model. This one. Okay. Can you go to transport analysis 1? Okay. Or you can use the IFN Workshop. It's the same. Okay. And if you want to check all the others IFN, you can go to Telegram channel. Okay. This is the link available. And this video explain how to use. Okay. You want to watch it later or now? Maybe later is okay. Okay. And yeah, this for next week's. Okay. Yeah. So IFN itself, I have a special section. Okay. There are many videos there that you can start to watch if you want later. Okay. There's public lecture also. Okay. The slide and several labs. Okay. And how to calibrate. Okay. And more deeply mathematics. Okay. And the beauty of the mathematics itself. It was also highlighted in the UN, United Nations, okay, based on IFN, okay, several times. And IFN is not only used for traffic, so we can also use for AI, a recommendation system and so on. Okay, and this is for supervised learning. Okay, so the next time we can discuss about the second part, transport policy analysis 2. Okay, how we will deal with more detail, how to generate policy alternative and so on. So you can still watch more detail later. Okay, so I hope this is good enough for the introduction. So let's start more detail now. Let's go to the policy analysis. Okay, here. Let me open the slide. It's a bit bigger. Okay. Yes. Can you see the okay? So policy analysis 1. So let's discuss a simple topic here. First, we'll discuss what is strongly connected network. Okay, what is pre-matrix. Okay, and then for your project, you need to create what is called pre-scenario and alternative scenario. Okay, and we'll discuss a little bit about stochastic matrix and ideal flow and performance. Okay, so okay, so let's start with this. Yeah, transport network. Right? So in any transportation network, okay, so you can go somewhere, right? And then you should be able to go home. Otherwise, it is not transportation network. Yeah. So in graph theory, we say this property is called strongly connected. Yeah. So when people can go somewhere and then go back home, this is the terminology is strongly connected network. Yeah. In linear algebra, okay, if you put this network into matrix, okay, this matrix is called irreducible. So in this example, okay, the left side, the left network here is not strongly connected. And the right one is. Why? Can you notice? From A, I can go to B. B can go to C and come back again. So, but once I go to the right side, okay, from A to D, I cannot go back to A, isn't it? Yeah. From B, I can go to E, okay, and then from here I can go up and down here, but I cannot go back to B. So cannot go home. So this is not transport network. Okay. So then what you can do to make it strongly connected, okay? One way is you need to make, for example, yeah, just C, F to C now they come back. So in that case, you have per center view, really? Okay, I'm more about this. Okay, wait. View. Can't show. Okay, I don't use one. Okay, I remove that. So I will go to screen 2. Yeah. And then okay. Can you see? Okay. So up here. So the left side here is not transport network. Yeah, the right side is. So transport network must be strongly connected. Yeah, the jargon is terminology is strongly connected network, or is that is equal to irreducible. Is that okay? Just name. Okay. Next, in any node, okay, we assume that the sum of inflow is equal to the sum of outflow. Okay, so in this case, for example, here, can you see? Highlight. Yeah. No, cannot see. This one. Okay, so yeah, so point 2. Yeah. So going in is 2, right? And then going out. Oh, this is 2 and 1. So become 3, right? And then going out is 1, 1, 1, so 3 also. Yeah. So in any node, the number of flow in, the sum of flow in equal to the sum of flow out. So a matrix that have this kind of characteristic, okay, that the sum of row equal to the sum of columns. This is the sum of row, this is the sum of column. Okay, so it exactly the same. You see this? This is 8, 8, 3, 3. Yeah, can you see? 16, 16, 12, 12. Nah, exactly the same. Then this is called Prima-Check. Okay, that's the name. Okay, next. Now, if you want to IFN manually, okay, so in this case, you can draw manually. Okay, say for example, 4 nodes, 5 nodes. Okay, and then you can set any node as your origin. Okay, and then you can set any flow, for example, 100 into that node origin. Okay, and then when that node has only one in, okay, and one out, that means the same amount of flow will continue. Okay, when the node has more than one in edge, okay, and the sum of flow from in edge into the flow set, okay, you can put that, and then you distribute based on certain probability distribution that you set. Okay, and then the ratio between the flow distribution, okay, you can divide by, for example, any statistic of the flow, for example, the minimum flow. Okay, I give you an example here. Say I have 5 nodes like this. Okay, let's assume for a while that you are distributing in each node, okay, equal distribution. Is that okay? Just assumption first. Say I have in node 5, I put 100. Okay, and then this 100 flow will go to node 1, isn't it? Okay, from node 1, I distribute equal distribution, so 50-50. Okay, so now 50 reach node 2, what you will do? So if 50 reach node 2, then distribute it into 2 links, right? Okay, in that case, you 50 divided by 2, yeah? 25, 25. Is that okay? Clear? Okay. Next, 25 here. Okay, again, in here divided by 2, okay, because this is have 2 links. So you get 12.5, 12.5. Okay. Now, reach node 4. Okay. This one, there is no other link, right? So then you just continue. Yeah. Is it clear or not? Yeah. Now, in node 5, okay, you check, okay. This one, 150, 12, 25, 12.5 and 12.5 must be equal to the outflow, yeah, which is 100. Oh, correct, yeah. So this is ideal flow. Okay, so we already reached ideal flow here in point E. Okay? But if you want to make it integer, right, of course, you just divide by the minimum, yeah. So in this case, you can get easy number, okay. So you can scale up and down, okay. Easy or not? Super easy, yeah. So you can try by yourself, okay. You draw on paper or in drawing, okay. And then you can also calculate by hand. Now, if only 4, 5 until 7 nodes, you can draw by hand, and then you can calculate by yourself. No need equal, eh? So you can set distribution. Okay. Okay. So let's take example. Okay. You have 2 scenario. Okay. This is what you need to do in practice, yeah, today. Okay. So you have 2 network. This is called base scenario. So this is the current condition. And you have a second network. It is exactly the same, but you change a little bit here. So instead of 2 lanes, now you make it 3 lanes. So the capacity here I set as the number of lanes. Is this clear or not? Okay. So the difference between base scenario and alternative scenario in this example, because this is a very simple example, you see everything is the same except DE here. 2 lanes now become 3 lanes. So what's the meaning? There is a road widening. There is road widening in DE. Is it clear? Okay. So then you need to set, okay, this number of lane, okay, you need to set in PCU per hour. Okay. So say, so I put that this network into matrix. Okay, so you put that into Excel. Okay, so I have A, B, C, D, E, F, right? And then you put into matrix, something like this. Yeah, this is the capacity matrix. So I put A, B, C, D, E, F. Okay, and then C here represent capacity matrix. Yeah, in the number of lanes per direction. Yeah, so what is this yellow part? Yellow part from the data that we have. Yeah, so A to D is 1, right? D to E is 2. Yeah, so there A to D is 1, yeah? D to E is 2, and so on. Is it clear? Can you make this next step? Yeah, this is just type. Okay, And then because we said the capacity per lane is 1,800 PCU per hour, okay? We get this from last meeting. Remember, we discussed about traffic flow theory, yeah, last week. Yeah, you have assignment also, right? So in that assignment, you decide the capacity, right? So you know the capacity per lane is how much, yeah? About 112 to 2,500, yeah? So this is, we said 1,800. So, and then one lane, 1,800. So that I can convert that capacity matrix from one lane, okay, now become PCU per hour per direction. Yeah. Both are capacity matrix, but have different unit. Yeah, this is the number of lane. This one is PCU per hour per direction. Is it clear? Okay, let's assume there's a total demand, okay, 17,500, okay, and then maximum speed, let's assume all the same, 40, so that clear, yeah? And then also the links all the same, okay, at this point, so that easier to compute, yeah? It's just an example. Otherwise, you need to create the same matrix again for maximum speed and max for the link. Okay. So, and from the capacity matrix, because we use proportional, okay. So this is the input, right? The capacity matrix as the input, the number of lanes. Okay. So I need to know, okay, what is the probability to turn left, right, or go straight in its intersection? Okay, so if you want to know that, then you need to put camera or you need to put some sensing device in the intersection, isn't it? Okay, but remember in one city there are millions. No, not millions. I think. Oh yeah. Last Metro Manila last time I computed about almost 500,000 nodes. Okay, so if in each node you have say 4 direction, that means you have 2 million sensor you need to put. Okay, that's very costly. So especially if your intersection is very small. Okay, so in that case, let's do assumption. Okay, now, this is the weakness, but at the same time, this is also the strength. Okay, so you assume that the probability of turning distribution in each intersection depends on the proportion of the capacity, right? So the wider the road, okay, the larger the probability. The smaller the road, the smaller probability. If you don't like that, you put the camera or you put certain sensing device there, and then you use the actual probability. Okay, so if you don't have the data, you can still do by assuming. If you have data, of course, the real data matters. They don't use assumption. Is it clear? Okay. Now, in this case, I have A to B is 1, A to D is 1. So in this case, I just compute easily. Okay, how? We just divide, yeah. So that the sum on the right hand side here is 1. So remember, we want to calculate probability, okay, going up. Okay. So in that case, the sum of the probability is 1. Okay, so how to do that? You just sum to the right. Okay, this is 2. So 1 divided by 2 is half, right? This one, 1 plus 1 plus 1 is 3. And then 1 divided by 3 is 1/3, and so on. You see? Okay. So this is this simple proportional technique. Okay, we will get Markov stochastic matrix. Okay. And then from there, we can calculate ideal flow. So what is ideal flow? Okay, ideal flow network is the limiting distribution, okay, of relative flow, okay, on a simple, strongly connected network subject to constraint of flow conservation. So in simple term, okay, so ideal flow is just relative flow, okay, in the network, in the transport network, a strongly connected network, where the flow is conserved. Yeah. So in this case, pre-matching. So in 2 words, the ideal flow is irreducible pre-matching. As simple as that. Okay. So because this is a relative flow, okay, so you have certain flow, you divide by the statistic of that flow. Okay, you can divide by minimum, maximum, average, standard deviation, and so on. So any statistic of the flow. Okay, so in this case, I use minimum so that easier for you. Okay, so now the real computation is actually based on Markov chain. Yeah? Next time we will discuss more detail about this. Yeah. Okay. At this point, I developed the software already, so all you don't need to compute manually. Okay, all you need to do is just look at this formula. Is this one? The data is this is your data input. S. What is S? S is the stochastic matrix a while ago. This one. Okay. This is the theory of ideal flow. Actually, did not start from capacity. It starts from the stochastic matrix. Okay, so from capacity to stochastic matrix, this is the actual weakness of the method. So then you just minus with identity matrix. Okay, you want to get another input is the total flow kappa. Okay, this must be set. Okay, and then if you know this, you can calculate. So you have the stochastic matrix. I is identity matrix. J is just factor of 1 in a row, transpose in row. And then this is kappa is another parameter, which is the total flow in the network, yeah, total demand. So once you know that, you can calculate the pi. This is the node values. And then you can calculate the F, the flow matrix. Okay, so using the IFN software or using the Excel add-ins, you can already calculate all of this. Okay, so you will see once we will practice, okay, you will get this kind of matrix, yeah, ideal flow network. Okay, because ideal flow is relative flow, so you can scale up and down. Okay, so in here I get 38 as my value. Okay, this is I put them all in the integer. Okay, but remember our total demand in the actual problem is 17,500. So in that case, I calibrate this ideal flow. Okay, so I divide 17,500 with 38. Yeah. So then I have this scaling factor. I multiply with all these numbers here. So this is the flow that I have in the real world. Yeah, this is in the ideal world. This is the flow in the real world. Is it clear? Okay. Once you have the flow in the real world, all you need to do is divide with the capacity. Yeah. Okay. So you have the capacity, but remember you need to use the same unit, right? Well, you cannot divide by the number of lanes because the flow in the real world is PCU per hour. So the capacity must be also PCU per hour. Yeah. So in that case, you get the VC ratio or the congestion. Yeah. Congestion is just the flow divided by the capacity. So you get this value. So because you said earlier maximum congestion is 0.9, so you get that. Okay. So after that, what you will do, okay, you can calculate once you get the congestion easy. Yeah. So once you get the congestion value, okay, you can calculate the speed, you can calculate the travel time, you calculate the delay. Okay. So A here is adjacency matrix, which is the network. Okay. From the network, you will know the capacity. Okay. U here is the matrix of maximum speed. L is the matrix of length. Okay. In a while ago, I assumed 1. here I assume like 40 or 60 kilometers per hour, right? But you can set different values for each link. Okay. From the capacity matrix, we use proportion, we can get the stochastic matrix. From the stochastic matrix, we can get the flow matrix. Okay. From the flow matrix and capacity matrix, you get the congestion. Yeah, G is the congestion. Once you know the congestion, okay, you can calculate the velocity, the speed, yeah, for each link. You can calculate also the T is the travel time and the delay. Okay, the formula we already learned last week. Okay, this formula from last week. Yeah, so this is from Greensill, remember? Okay, so and then travel time is just minimum travel time. Okay, you have this one is the free flow speed, maximum speed. Okay, this is the Greensill formula. So the speed depends on the maximum speed and the what is this? This is the congestion, yeah. This is the congestion. So and then the travel time is the length divided by the maximum speed, minimum travel time. And then the real travel time is this one, yeah. Based on this speed, yeah? L divided by speed, yeah. So I just put this in the bottom, and this one could become up, right? So exact formula. And then the delay is simple, T minus T0. Okay, so that means travel time minus minimum travel time. Yeah. So then you get the value. Okay. So if you look at this, the software is actually rather simple. So only based on this one. Yeah. So you can also use other method. This is based on Bureau Public Work in the US, 64. Okay. The formula is slightly different, so become non-linear. Okay. So in this case, the minimum travel time is the same. Okay. But the travel time changed. Yeah. The travel time a while ago I used Greensill, right? This one. So in using PPR, I calculate the travel time based on certain parameter. Okay, this is the set suggested value, but you can change this one. Okay. And this is the minimum travel time. Okay. This is the gamma is 15, eta is 4, and then W here is the congestion level. Yeah. And then the speed is just length divided by the time. Okay. Delay is the time divided minus with the minimum travel time. Yeah. So then we can calculate all. Yeah? So based on that congestion level, okay, and the length and the maximum speed, so you can calculate all. And then you can take the average. Okay. Be careful when you take the average. You don't take average to include the zero. So all the zeros is not included in the average. Okay, otherwise become too low. Okay. Only the positive values that you put as the average. So here is the average become 6 point something, yeah, 15 and so on. So this is for the base scenario. Then you do the same thing for the alternative scenario, and then you compare. Okay, or is it better or not? Yeah. So of course, the basis comparison of base scenario is, for example, yeah, travel time is 6.4 in the base scenario, and then in alternative scenario become 5 minutes. Yeah. So in this case, improve, right? The same thing, speed a while ago is 15, now become 16, so improve. Yeah? This is for the whole network. The same thing with the delay. Yeah, so you compare the base scenario and the alternative scenario. Okay. So IFN is similar to queuing theory. So this is a steady state solution. So it's a long-term equilibrium. Okay. It's based on maximum entropy principle. That means if you don't have data, you can just use the data that you have. Okay. If you have data, then use your data. Okay. So and the flow are conserved. So you only need minimum data. In fact, you don't need data at all. Okay, all you need is just the network data that you can get from OSM or from Google Map. Okay, and then actually you can also adjust the flow automatically. So in this case, you can check, okay, the value of topology, yeah, the network structure. So it's very sound theoretical basis for network assignment. And instead of using Walther principle in the classical way, you can use also similar, okay, Nash equilibrium and Pareto optima, okay, for the equilibrium condition. Yeah. So up to here, is there any question? Yeah. In TIA, yeah, traffic impact assessment, you can use also. Yeah. So if you want, you can also use that. Okay. So do you want to practice? I give you time to practice, and then yeah, this example, the simple network only 6 nodes. Is it okay to practice so that you can get a better understanding? Mm. Oh, following. So now, if you have so I have Excel here. Okay, this one Excel. Can you see my Excel? Let me put that here. Okay. Let me see. So let's practice together if you want in Excel, right? So I will open this slide again, and I will put it in right beside that. Here it is. Okay, I will share the screen, the whole screen now, entire screen. Can you see it? Okay, so this is the slide I want to go. So I have, let's say I have A, B, C, D, E, and F, right? So I just copy this. And I will put here paste as special plus post, right? So that I will have exactly the same. Okay, so I have A to B is 1. Okay, and then A to D is 1. Then here is 1, here's 1, and then here is 1. Is that correct? Here's 2, here E. Here's 2, and then here's 2, here's 2, and then C. 1, no, 1, and 1. Okay, let's format it a little bit smaller. So I will put 4. Okay, there it is. Conditional formatting. Okay. Okay. This is our input. Okay. So then we can say capacity per lane is 1,800, right? This one is PCU per hour. Okay, total demand. Okay. Demand is 17,500. Okay, the max speed is 40. Okay, and then link length, say you put 1 kilometer, yeah. Kilometer, here is the PPH, here is PCU per hour, exactly the same. Okay, so these are the input that we have. So I put it as yellow so that we see that. Okay, so this is the capacity matrix C in number of lanes. Okay, so I can copy this exact here, right? But now this one is in terms of number of capacity per lane. Yeah. So then here I just multiply this one. Right? Okay, let's give a name so that you will see. Okay, so this one is capacity per lane. So I give name. Okay, capacity per lane in the name box. Can you see? Okay, and then here I just put equal above. Okay, multiply by the capacity per lane. There. Then I can copy all. Okay. Yeah. So I got exactly this value in the right side. Is that okay? Now I want to get the stochastic matrix, right? Okay, so I need to get the stochastic matrix. So I copy here. Okay, now I change the name S, yeah, stochastic matrix. Yeah. So let's set this the format. Okay, I just put into smaller. Okay, 4. Okay, yeah. So I put the sum here. And then I put the sum also here. Let me move it. And let's put the sum. Okay. So the sum in here, okay. You can either put the sum in here or at the bottom, it's up to you. You can choose. Okay. I will move this somewhere there. Okay. Okay. Now the sum, of course, you just put sum, right? The whole things. You see? And this is the sum. Okay. You can also copy the sum in here if you want. Not necessary, but if you want. Yeah. Then this one, stochastic matrix is just equal. Okay. You can choose, yeah, either this one or that one. So you can just I choose here. Divide it by the sum, yeah. Divided by the sum. But because I need to put so that the sum is in the right hand side is 1. Okay. So in that case, the I, yeah, I need to put dollar sign, yeah. Put dollar sign here. Okay. Then I copy to all. There I got the stochastic matrix. You see? So then this one, the sum, I just copy to this side. There. The sum is all 1, correct? Okay. You don't like to see numbers like this, you can put it into a decimal, fractions. Right. So I can put it in fraction if you want. Format out of it. Yeah. Okay. But you can also put it into fraction. Okay, so you get the stochastic matrix, yeah. So let's go here. That one, stochastic matrix. Exactly the same. Yeah. Then you need to install the IFN add-ins. Okay, once you have that, you need to install the IFN add-ins. Yeah, to compute the flow. Okay. you need to compute using this one, which is complicated to compute. Yeah. Next time I will explain in here, but today we just use the software. Yeah. So I will just copy this again. Okay, and then I put down here. Okay. Copy, put down here. Okay, now I change this into F. Right? So, oh, okay. So what happened is I just put like this, okay, n underscore. Okay, so I want to get from capacity to ideal flow or from stochastics, okay, from stochastic matrix to ideal flow. You can also do this. Yeah. So I got from stochastic to ideal flow. Well, this is the stochastic matrix, right? So you can set, after that you can set the capacity, the total flow, or you don't set. It's okay also. And then what you do is you highlight the whole things, yeah, and then you edit, and then you press Shift, Control, and Enter together. There, I got the ideal flow, yeah. So once I get the ideal flow, what I will do is I get the sum to check whether this is really ideal flow or not. You check, yeah. So I put the sum. If this is ideal flow, okay, the sum of row must be equal to the sum of column, right? So this is the sum of total, the sum of the whole things here. Oh, 38. Yeah, this is exactly the same as this one. See, 38. Okay. Yeah, I just put different color. You don't like this, I can change that color if you want. That color. Maybe this one. Oh, exactly. Okay. So, but our total demand is 17,500. Okay. Our total network is 38. So then you need to calculate the scaling. Okay, so the scaling is the total demand, this one, divided by the total in the ideal flow. This one. Oh, this is our scaling, yeah. So in that case, now I want to get the whole thing again. In the real world, okay, this is in the ideal flow. So what is the actual ideal flow in the real world? Is simple, yeah. This F multiplied by this scaling, yeah. Okay, let's keep name now. Scaling, I will put here scaling. Scaling. Okay. In this case, I will just put scaling multiplied by F. Okay. Sorry, I need to delete all of this first. Okay, and then I equal scaling multiplied by the F. Okay, then I just copy to all. There. See, I got exactly 17,900. Yeah, and this is the value. So I got the real workflow that I want. Okay. Then you said I want to get the congestion. Ah, congestion. So the G. Yeah. Right. So let's copy again. So I want to get the congestion level. I copy this so that I can get the name. Okay, I don't need the sum in the congestion. So I name it congestion G. Okay, what is congestion? The actual flow, yeah, this one, divided by the capacity, yeah. But this is divided by 0 is not okay, right? So this is error. So in that case, you put if error, yeah, then 0. Okay. There. And then we just copy to all. There I get the congestion value. Yeah. Yeah, exactly. Yeah. From here, you can just calculate, for example, yeah, the next one is just simple, yeah. Calculate is just based on this formula only. So, example, I want to get the V, okay, this one, right? So, I want to get the V, I copy again here. Okay, so I want to get the V. Now I change this to V. Okay, to get the V, I need to get the maximum speed. Okay, yeah, maximum speed I put here. I keep name max speed. Okay, so V is what is the formula? This one, yeah. Max speed divided by 2. Okay, so here I put equal the max speed. What is the max speed? This one, max speed divided by 2, yeah, and then multiply by, okay, parenthesis 1 plus square root of 1 minus the G, yeah, this one. Okay, close it and then close it again. Okay. Oh, okay. This correct. Yes. Oh, oh, this is supposed to be like that, but there's a problem. Okay, this one is actually 0. So then, okay, you need to put if, yeah. If this one is not 0, then do this, yeah. Otherwise 0. Yeah. Right. Okay, then copy, yeah. There. Okay, so I got the speed. Yeah, quite. Yeah, 30. I can make it a little bit, and then the format. Yeah. Yeah. Clear or not? Can you do it? You practice, and if you have question, you ask. Okay, I will give you time. I will pause the recording. You can share a screen, John. Can you share your screen? I do not see you. Okay, starting to share. What do you want to ask? The stochastic?
I think my Excel is lagging, sir.
Oh, okay.
The next steps are after when we are doing the F matrix, sir.
You need to install the IFN Excel add-ins.
Yes, sir.
Did you
I
install?
found the N over stochastic ideal.
Okay,
row,
so
sir.
it works already. So in that case, you just n underscore equal n underscore, and then you select among this menu, and say you can choose which one you want from capacity or from stochastic. So if you get from stochastic, so you just highlight the whole stochastic matrix. Okay, once you highlight the whole stochastic matrix, okay, the step is, okay, you enter first, okay, and then you go to the edit. Okay, edit. After that, okay, you highlight everything and you select the whole matrix for the flow matrix, and then you press Shift Control Enter. Yeah, so I will type for everyone. Okay, select. Okay, and then edit. Edit, you can also use F2 in Windows, and then Shift plus Control plus Enter. Yeah, I put in the chat. Actually, you can also check the documentation.
Hello, sir.
Okay, yes.
Is this correct, sir?
Oh, let me see.
Which cells will I highlight, sir?
Okay, so this is correct. You already have the L until Q, right? That's correct. Okay, so you enter first, no problem.
Enter first, sir.
Oh, why don't you put it? Why don't you put this in L20? Okay,
L20, sir.
wait. You enter first, and then you move it to L20.
This one, sir, equals n over stochastic.
Yeah, you put it in L20, right? So that below A.
L20, sir, then up to the last cell.
Oh, wait. Why your is lagging? I cannot see actually what you are sharing.
Oh, sorry, sir.
Is anyone can see job and sharing? Okay.
Wait, sir, I'll reshare, sir.
No problem. So, okay, can I show using my Excel in that case?
This one, sir.
Oh, okay. So, see. Okay. No, that's correct a while ago, Joven. Okay, can you put escape first so that you can see? Okay. Okay, now you are in L20, right? And then in this case, you put M stochastic to ideal flow L12 until Q17 in your case.
This one, sir.
Yes. Okay, and then close it. Close
The
parenthesis. Close parenthesis. Close
okay, sir.
parenthesis. Enter.
Enter only, sir.
Enter only. Enter only. Okay, no
Then
problem. And then you hold shift key and then use arrow key to the right until there, and then down until F. Okay. Now you edit here you edit here. You put your mouse.
okay, sir.
Okay. Okay. And then you press Shift Control Enter together.
Shift Control Enter.
Huh? What?
I
Again,
don't
again.
again, sir.
Underscore and enter.
Oh.
You delete first. In that case, you delete everything. Then, okay. Okay, and then close parenthesis. Enter.
This one, sir.
Yes, enter.
Then Shift Control Enter.
Shift, yeah, Shift Control Enter, suppose.
Y. Shape
A
control.
while ago, did you press enter?
Yes, sir. This
Yes.
one.
Okay. Yes. Okay. And then you highlight all things until there down. Okay. And then edit. And then shift control and enter together.
There's
Oh,
a problem, sir.
there's a problem. Oh,
Maybe the add-in, sir. I did not install it properly.
let us see. Go to add-ins and then go. Oh, oh, there, you need to click.
I will redo it, sir, again.
Okay. If not, okay, you can add, for example, okay. Now put comma before.
Where, sir? Here, sir.
Yeah, put comma. No, before parentheses.
Before where, sir?
Before parentheses, you put comma, and then you can. No. Before end parentheses.
Before in.
Comma, and then you can put 100, for example. What will happen? Enter.
Percent, sir?
No percent, just 100.
100, sir.
Yes.
Okay, sir.
Enter. And then the same thing, you highlight and press down. And it's supposed to be shift control enter. Oh, why?
Maybe my other classmates can share there, sir.
Okay.
I'll figure out.
How about the others? Do you also have same problem, or you check the manual together with that Excel add-ins? There's a documentation. Okay, so there's a tutorial also there. And you can also draw your network, based on that. Yeah. Anyway, you already did it, so I don't know what is the problem there that it doesn't work in your case. But is it only you or others also the same? Yeah. Now you can also do exactly the same thing there. Okay, you can just copy that. Okay, and then go to you go to IFN transport. Can I share my screen? Okay. If you go to IFN transport here, you can also do the same thing. Or if you want the matrix side, okay. So this is the IFN transport virtual lab. Okay. And the IFN transport is something here. So this is the matrix. Can you see? This is the matrix. Okay. This is exactly like the Excel. Okay. So in here, exactly similar to Excel, but you need to put in this format, yeah. Number and then space, and then at the end of each row you need to put a semicolon. Okay, and then this is example of capacity matrix. Okay, and this is the example of link matrix. Okay. This is the example of maximum speed. Okay. These are the three input, right? So in here I use lane. Okay. In this case I have a multiplier. In this case, a while ago you use 1.8, and here I use 1.5. It's the same. And then you set the maximum congestion, and then what you will use, for example, clean seal, and then you calculate there. Once you calculate, you will get this is the capacity, this is the link distance, okay? This is the stochastic matrix, and then you can get this is the one that computed. A little bit more complex to compute this one. right? And this is the ideal flow. And then finally you get the congestion matrix. Yeah. Yeah. Minimum travel time, the travel time, the speed, and the delay. Yeah. Eventually you get all the network performance, okay, the same thing. So the internal computation of IFN transport is exactly that matrix. Okay, in here I just make it so that the format is different. Only the format of input and output is different. Okay, but internally we still use exactly the same matrices. Okay. So basically you know what is inside. Okay. Isn't that better? No? All right. So again, IFN is not just for transport. So these are the example of the transport. You can also use for example, for music, for AI, and so on. Yeah. So you can even use for any other purposes if you want. Okay. So anyone else want to share screen? So once you can do this, then you practically can do your project already. Is this something interesting for you? I don't know. Yes, Glenn.
Hi, sir. I have a question because I have the same concern as Joe. Was that Joven earlier?
Yes.
Um, would you be able to give us the copy of the Excel file you just did so
Also,
we can compare it with our
sure,
own Excel?
I can send you now. Okay,
Thank you, sir.
I can send it now. I'll put it in my desktop. Uh, I can send you now in Zoom. Is it okay?
Yes, sir. Thank you po.
Okay. Now I will send it to you. How to send to everyone in Zoom. All right. Okay. So I put in the chat. Oh, fine. Really? Oh, because I knew. Again. Okay, this is the example. Did you get it?
Yes, sir.
Hmm. Is it working in your place?
think we're having a problem with the add-in, sir, because on my end, the one that was displayed by Joben earlier was
Same problem?
yes, sir. But we'll try to figure it out first.
Okay, so in that case, I don't know what happened. Let's do it in the online. Is it okay?
So do we need a genuine Microsoft? Maybe that's the problem.
Not genuine Microsoft.
Because when the one you sent, sir, displayed the same case up with me now.
Oh, still problem.
Name.
Name.
Yes, sir.
Oh, why? Okay, so forget about the Excel in that case. Okay. Oh, if you have no function and stochastic that something, that means you did not install. Yeah. You download from Moodle and then you install. Is it just because of genuine something or because there is also possibility because of security in Excel? You need to figure out how to install Excel add-ins, and then you need to check the security problem there. I think several students before also talk about the problem in security that you need to set. Okay, so anyway. Okay, so forget about this for a while. Okay, I can send you the latest manual, in that case version 8, okay, which include the security problems that handle that. Probably, I hope that will help you. Okay. So, version 8. So in the security problems, okay, this one. Can you see my guide in this version 8? So you have it like this, right? Okay. After you unzip, you will get that. Okay. You double click. You're supposed to have in this folder. Okay. But when you sometimes it doesn't work because of macro not allowed. So you need to enable the macro. Okay. So that is the security problem that usually happen. Okay, so if your installation is right, you will see in the menu when you do right click, you will have a menu of ideal flow. Okay. So and then you can also check in your file, should be there. Okay, so that's the update on the security problem. Okay, so I hope this helped. I don't know. If not, so let's do it in website. That's the easiest for you. Okay. Oh, you have a Microsoft account, but you have a so if you have a Microsoft account and you still have the same problem, probably Microsoft does not allow because of certain security. So you check the security problem that you enable this from outside, right? Because this is not from Microsoft, so you need to enable that. Okay. What strange? if it is enabled, why the menu is working? No, it's not working. Supposed to be the menu also not working. So, anyway, okay. Can you do it in online IFN transport? The same problem. The same problem. You want me to guide you? Okay, let's do it. Let's go to the slide again. So you already have this, okay? Let me share it with you. I will share with you the whole screen. Maybe I will close this one. I'll close this one. And I will open this one. Can you see? Can you see the slide? Yeah, okay. So the same thing here. So IFN Transport have two versions at this point. Okay, one is in Python, so you can go to GitHub. Okay. And you can also go to the online version. So let's do it this one. Okay. So if you do it in Python with GitHub, so this is the one that you need to do. You download the Anaconda, download the PIP, and then okay. So this is the one in GitHub. You're supposed to have this. If you run, supposed to have this one. Okay. And then you can this is the node and link that you're supposed to make. Okay. Can you type this one? Okay. So you can also export from OSM a while ago. Okay. So let's do this. Okay. Let's practice this. So can you put this into the matrix? Mine's work on. Okay. So you need to unblock. Okay. Very good. See the security problem, right? So you need to unblock the ideal flow XLAM. Mark, do you want to share how do you unblock so that the others can also see?
Hi, sir. What I did is I just uh, unblock the file itself. Just go to the file
I go
and
to,
then right click and find the unblock in the security features.
okay. So you go to the file and then right click and then unblock.
Yes, sir.
Okay. So Ben, Glenn, and the others, please try that technique to unblock. So it's just our security problems of Windows. So you can practice this by creating the network. Okay, first you put node coordinate. So when you want to put node coordinate, you set node ID in here A, B, C, D, E, F, and then X and Y. The value of X and Y is up to you. Okay, so this is the example. I can put say node ID 1, 2, 3, 4, 5, and then these are the value that I put. Yeah, you can set any numbers as long as it represents similar to the drawing, right? And then you can set this value available. Okay, and then you can set the link table. Yeah, link table consists of link ID, node 1, node 2, capacity, distance, and maximum speed. Yeah, so in this case, you can set directly. Okay, so look at the matrix that you have. Okay, so link ID is 1, 2, 3 until the whole number of links. Okay. And then this one in here mean A, right? This one 2 mean B. And then capacity is exactly this one. 1,800. Distance is the length. In here is all 1. And then the max width is all 40, right? So this is the input data that you need to put. Yeah. So once you put this node and links, okay, so you can put IFN transport, okay, and you can set what is the total flow at certain congestion level. Okay, so possible. So let's do that. Yeah. So I will go to actually if you go to IFN transport itself. Can you see? If you go to IFN transport itself, this example is already there, I think. I forgot which one is this. Maybe no. Oh yeah, this one, right? So this example is already in here. So I put 2 blocks number or 2 blocks alphabet is okay. Yeah. So you don't need to type, it's already there in the example. Can you see? I can transport. Yeah. You can use either 2 blocks number or 2 blocks alphabet. Okay, let's try first this one. 2 blocks weakly connected. Say if you use 2 block weakly connected, then you click this one, test if strongly connected, it will say no. Yeah. So the network is weakly connected. So it's not strong. So if you look at the drawing here, so let me so if you look at the drawings, okay. So from A go to D, from B go to E, from C go to F, but cannot come back, right? So this is weakly connected. Right. Can you see? Yeah, so this is cannot come back. Yeah. So from the left side can go to the right side, but cannot come back to the left side. So this is weakly connected. Yeah. So to make it strongly connected, so I will put here 2 blocks alphabet here. It changed. So this one have 6 nodes and the same 11 values of the links. And you can test this is strongly connected. Yeah. And that one is strongly connected. Okay. So and then you can check the network there. This one come back. Is this okay? So say you want to look for link ID. If you want to find the node, for example, I want to find node A. There it will show node A. Can you see? with different color. Yeah. So if I want to see link ID 5, there, let's say this is link ID 5. This is when your network is big, this is very useful. Okay, of course, small like this you don't see usefulness, but when your network is very big, you want to know which one is the link that you are in interest, right? So this is very useful, right? And you can also put link by node ID. Yeah. So for example, I want to see from F, comma, yeah, C. Yeah. This is the link. Yeah. So, or you can find the path. Yeah. I want to find the shortest path. Yeah. From A to F. Yeah. This is the shortest one. Can you see that? So in here is better than Excel. Okay. So this is based on network alone. Okay. So then what you will do is, okay, so I don't do anything. So no selection of action. Okay. So once you have the network, okay, so all you need to do is to check the model here. Look at this. This is using what? Look at the capacity. Okay, the capacity here is 1. That means number of lane, right? Okay, it's not this hue. So in this case, you need to check. Okay, this is based on number of lane. Yeah, so I put in here 1,800. Okay, which model you want? You want green shield? Let's put green shield. And then what is the constraint a while ago? Total flow, right? The total flow should be 17,500. Is that correct? So let's start that. Okay, and then this is the result. You calculate there. Total flow 17,500. So this is exactly the same as the Excel a while ago. Yeah? And then you can export to Excel. Okay, so from here you can start to see the congestion level. Okay, so change the congestion. This is more congested than the others. Nice. Usually it's better. Yeah. So I want to see the what is the speed. Nah? So the speed you can see the detail. This is 36.7. This one is 33. Okay, this is the link number. Okay, this link ID, and then this is the actual speed. Okay. If this is very complex like that, so you can change the zoom. For example, you change it to 5,000, so it will separate. Okay, and then you zoom it in a better way. Yeah, so you can find this. There, okay, clearer. Okay, so this is the speed 29 and 26. Of course, aside from this, you can also see it from the table. 29 and 26. So, right? So you get the flow, speed, density, yeah, including travel time, delay, even the stochastic is there. Okay, so if you want to add air pollution and so on, so based on this you can calculate. If you want to calculate the cost from here, you can calculate also, right? Okay. And then of course, this is base scenario. The next scenario you create again. So all you need to do is to create new tab, okay, and then do exactly the same, and then change the value. Now, so this is the main point. Okay, in any model, between the base scenario and the alternative scenario, you should have invariant. Okay, this is the main point. Okay, so in this case, the invariance is total flow. Okay, so for example, I set the total flow does not change. What's the meaning of total flow does not change? That means that the demand for the entire network do not change. What is the meaning of demand does not change for the entire network? That means the alternative scenario that you suggest will be done in the same year. right? Yeah. So how about if I change it in different year? Then you need to do regression so that you can get in different years. Yes. How do you enable the link? Which is in Excel or in the web? Glenn.
It's in IFN Transport. I'm trying to follow your instruction, but mine doesn't show the link between the nodes.
This one? Do you want to share your screen?
I'll share my screen, sir.
Okay. Okay. Oh, okay. Okay, so this one is scaling problem. Can I see the go up? Can you go up a little bit? Go up. Okay. This is the link, right? The link is already there. So the scaling is the problem. Go down and then change the scaling. For 100, what happened? Oh, can you select the field? Ceiling capacity, for example. That's strange. You cannot see the link.
No, there's no link connection between nodes.
Really? Oh, can I see the data? Data is from this one, from A to B. Why I can see and you cannot see? So let me see. Okay, come back to the go up. Can we see this one is 2 block alphabet? Okay. Can you click again? Refresh the browser. Okay. Okay, let's change that to 2 block alphabet. Okay, and then go down.
Okay.
There.
Okay. I just had to refresh the screen. Thank you, sir.
Yes. No problem. So with that, can you go until the result? You do until the result. So once you do until the result, okay, you save that into Excel, okay, and then you change the scenario, right? A while ago was base scenario, now you change to the alternative scenario. What did you change? Okay, only link. If you look at the slide, okay, link. One of them need to change, right? Link DE from two lanes now become 3 lanes. Yeah, that's the alternative scenario. Okay. Okay. So let's set the maximum congestion to 0.9. Okay. So if you set the maximum congestion 0.9, okay, you need to record the total flow. Okay. So the total flow between the base scenario and the alternative scenario should be the same. Okay, and then you compare. Okay, all you need to do is to compare. Okay, the maximum congestion. Initially, you said 0.9, right? Okay. After that, when you do alternative scenario, is it better or not? Okay. Is it more congested or less congested? Anyone else want to share screen? The result, no, I calculate the result, no output. Really? Okay, share your screen. June.
So can you see my screen?
Mm-hmm.
I am in the model, so I inputted. Is it right? 17,000.
Yes. Okay.
500.
Then,
Winfield
okay.
capacity is
Correct. Correct. And then,
then I'll go to the result.
can I see the network first?
Network.
Yes. Okay. And can I sit down? The drawing is still correct. Okay, good. Okay, now go to the last tab. Result.
This one.
Yes. Calculate.
I think there's something wrong with my computer.
Can I calculate? Oh, wait. Can I see your screen again? You cannot. When you click calculate, cannot calculate.
Yes, sir. Yeah,
I just suspect why this is suddenly not secure again.
oh, this one.
Yes, it's supposed to be secure. Can you use Chrome? This is Safari, right? Or this is Chrome already?
I think it's not Chrome. It's not updated.
Oh, okay. Can you use updated Chrome?
Yes, sir. I will try.
I think that's the strange. Why not secure? Okay. Browser is also a problem sometimes. So please use updated Chrome. I have no problem with the security. Anyone else have problem? Yeah. Oh, good. You want to share your screen? You can run your Excel. So what Mark Anthony share a while ago works. Thank you, Mark.
Can you see my screen now, sir?
Okay. See your screen. Oh. Okay, I can see your screen. Oh, it works.
Yes, sir.
Super.
I don't know, sir, if it's correct, sir. Up
Yeah.
to here.
You see your? Oh. I
G-
give you the computation in slide so you can just compare that if you want. So yes, it's correct, I think.
Okay, sir.
Yeah, 37.2.
That unblock is the crucial part.
Yeah, the crucial part. Okay. I also learned something then.
Thank you, sir.
Thank you. Yeah, thank you, Mark, Anthony. So with this, you can practice and you can do. And now in here is easy. Now you want to change the what is that? The capacity, right? The
Yes, sir.
DE, is that correct? No, yeah. Okay, no. DE is what is it? G7
G, sir.
in your case. No,
G7.
G7. Cell G7. From 2 now you change to 3, right?
This one, sir.
No, G7. Yeah, that one. Now you change to 3. Enter.
Okay, sir.
Okay, then you get alternative scenario. Is it
Yes. It all changes, sir.
it changes, right?
Yes, sir.
Okay. So then when you change that, what will happen to the congestion level?
Wait, sir. I will just undo.
Oh,
It will reduce
okay. A while ago was 0.9, now becomes 0.5,
0.6.
0.6, and then the maximum congestion in here is 0.7. Yeah?
Yes, sir.
So in that case, this improvement actually improved the whole network. Yeah?
Yes, sir.
So good. You see, yeah, you see. I hope you get the message. Okay. So you do trial error in the computer, then you can do it. I hope this is useful. Okay, so in any model, yeah, in any model, okay, so 3 things you need to check. Okay, one is calibration. Second is validation, right? The third one is verification. Okay, so 3 things. Validation means this is what you are doing a while ago, scaling a while ago. Yeah, from 17, from what is it, 30, 38, is that correct? From 38, okay, and then you change to 17,500. Okay, that is the one that you calibrate, meaning you get the parameter. In this case, the parameter is the scaling. Okay, and then second part is validation. Okay, whether the result is valid or not. Okay, so validation you need to implement, okay, in the real world. Okay, and then you need to test, okay, whether this is correct or not in the real world. Okay, so compared to traditional method, okay, you cannot do real validation in the real world. Why? Because traditional method of traffic assignment is based on average speed, average what's that? Delay, right? And then you say compare and then improve. Okay, in the model improve. Okay, but the question is, how are you going to check in the field? There is no way to do that. Okay, so but in IFN, this is what I'm suggesting. Okay, you don't do average, you do maximum congestion. Okay, what you are doing is do maximum congestion. So initially you set maximum congestion 0.9, for example, and then if improved becomes 0.8, for example, yeah, or becomes 0.7. Okay, of course not the same place. The maximum congestion improve, but in other place, right? In your case a while ago, the one that you put from 2 to 3 lanes, okay, the one that maximum congestion is not in DE, right? In the other place, correct? So once you know, okay, using this method, then you can go to the field. Where is the maximum congestion? Okay, might happen. Okay, in fact, using IFN, you can even with regression and so on, you can actually even predict when and where it may happen. Now, this is amazing. Okay, the traditional method will not give you this result, will not give you this kind of validation, because it will not tell you where. It will just tell you the whole network, then you take the average. This is a problem any transportation is just like a model, and then you just implement. After that, whether it's true or not, nobody knows, right? Whether you are lying or not, nobody knows. Okay, this is not will happen. This will not happen in IFN because you will know where and when. Okay, it may happen. Okay, and the third one, of course, to verify. Yeah, so whether if this is not correct, say the one that you check in the field is not really correct, then you get the feedback loop, right? You verify, okay, or maybe the way you do some of the assumption is incorrect. Then you can fix the assumption, okay, so that you can get the better result next time. Okay. That is science, no? Science means you get the feedback from the real world, you get the data, and then you improve your model. Okay. So IFN will allow you to do this kind of feedback loop. Okay. While the traditional method does not have this kind of feedback loop. Right? All you get is only the average, no? So once you get the average, how can you get the average, the whole network, which like 1 million nodes and 2 million links? You cannot get all this data. Okay. So yes, in the model you can get, but in the real world you cannot get all this data, isn't it? Then you cannot actually validate, you cannot even verify. So using IFN, you will single out the maximum congestion where, which link. So that is only one link. That means one or two links. Huh? So in that case, you can actually go there and check. Do you get the idea? Am I convincing enough or not? Okay, so next good things about this. Okay, now you have similar to architect, yeah. So some of you probably architect, right? So you draw the buildings, okay, and then the civil engineer usually calculate the structure, right? Okay, and then you build, correct? So the question is, can you actually simulate in the drawing? Okay, whether this one will have better result or not, better look, better strength or not, right? So now in transport, okay, in the past cannot do, but using IFN now you can do. For example, okay, you don't have any data, right? Because the road network, it is a new town, for example. Okay? The road network is not there yet. Okay? But using this, because you know the link capacity, right? How many lanes you design, right? Now you can see, you can check the condition, right? Correct or not? Before even build, you can already check where it will be congested. And then you can modify. Yeah? Oh, okay, this is congested here. So what will happen if I change this? Okay. In the drawing, you can already get that kind of result. Amazing. Okay. So then you optimize, no? You improve and improve until you can get the most satisfying result, and then you can implement that. Okay. Once you implement, what you will do? Verify. Okay? Whether it's actually in the most congested area, okay, is actually according to the model or not. So that is called validation, isn't it? You validate the actual result from the model with the real world. No? Okay. Without doing the real survey after the model. Okay. Usually what you are doing is you are doing the survey before the model, isn't it? That is for calibration only. Okay. Okay. In IFN, you need only one link to validate, you know. Okay. You don't need OD matrix anymore. This is the strength. Okay. So if you don't like one link, you can get 2 or 3 links to validate the whole network. Okay. Once you have that, then you need the second data collection. What is that? After you implement that in the real world, then you collect again. Where the most congested, okay? And then validate with the model whether this is actually correct. Oh, the congestion here is now actually improved, but in the model is 0.8. Yeah, in here is actually 0.85, for example. Then what is wrong? You can look at your model again. So probably certain parameter that you did not adjust and so on. So in the traditional method, we will still do the traditional method next time, okay? But when you do traditional method, there is no way to do this. To do this kind of validation, isn't it? Right? Because they are using zonal, they are using average. Average means the whole things you need to count. Okay, no, it's impossible. That's the same as telling lie actually. Because you cannot, there's no way to validate the whole things. So, okay, I hope using this mathematics and the program that's very simple, I hope you can start to use the real science. Okay, honesty. Yeah, not lying. Yeah. Planning supposed to be validated by the real world, not just plan and then present it or looks very nice. After that, nothing happened. Okay, that is not real plan. Plan should be implemented and then you get the feedback loop to improve again and so on. That's the process. No? Okay, give me feedback. If you have difficulty, tell. So you know how to use the Excel at least, okay? And you know how to use the web. Okay. And if you have difficulty, tell so that we can also learn from you. In fact, from the problems, then we can become stronger. Okay? When you see problem, don't be afraid. Yeah. When you see challenge and problems, okay, of course not nice, but at the same time it will make us stronger. Correct? Okay. So when we solve that problem, then we become stronger. This is not perfect, I know, but with this, let's keep improving this together. Come on, you share your screen. Some of you did not share. Yeah, Finn. You can share your screen, right? Oh, there. Oh, in Excel, huh?
Yes, sir.
Or
I'm just lost on this one, the travel time. I
what
forgot.
travel time? Or travel
Yeah.
time you go to the formula a while ago.
Yeah,
Which model do you use? The PPR or
the green shield, sir.
green shield? Okay.
Yeah, it's I think length over
Speed. So you get the speed first.
yeah, sir.
Okay. And then the link length is in kilometer, right? So
Yes, sir.
in this case, the T in here is link length divided by the speed. That is in
Hours.
hours. Then you multiply by 60.
Okay.
Okay, to get the minute. Well,
And then for this one,
the same.
you also multiply by 60.
Yes, because this is the same. Okay, multiply by 60, you get the minutes. Unit matters, yeah. The formula does not give you the conversion of the unit. Okay, so you get 2 minutes No, in 1 kilometer, 2 minutes. That's okay. Right?
But on the minimum, sir,
The minimum means, okay, if you use 40, in here is 40, right? Or how do you get the minimum? Oh, 60. You are using 60 here. Eh? No.
yes, sir.
Link length divided by
Uh,
Q47. Where is Q47? No. You need to divide by the maximum speed.
okay. That's it. So it should be
Where is
this
the
one.
there? That one. Okay. So all for all. Then now you can minus, okay, the t minus t0, that is the delay.
Yes, sir.
See, now you get the delay. Easy.
I just have to do the based on the website, sir. I'll try that one.
Okay, so now do it the website. This in Excel you can do maybe up to 20 note, but
Yes.
once you go 20 or beyond, suddenly you get overwhelmed, right? But this
Yes.
is nice to practice, you know, so that you can, if you want to play, okay, to make the research, okay, the purpose I'm doing this is for research, no? So if you want to do research in IFN, what will happen if I do this and that? Excel is very nice, right? But
For the assignment, sir, is using Excel also fine for submission of that?
no, of course, no problem.
Yeah,
But
it's just 5 to 6 notes.
if you use Excel for your project, is that what you want?
No, for the assignment.
Oh, for the
on
assignment is fine. Yeah, for the project, if you want to use Excel, okay, can you create something more interesting than just a real world problem? Can you make it more theoretical, for example? Okay, I give you the clue. Okay, I give you the clue. So, in Moodle, Revoledo, okay, can you go almost to the bottom? There is a video about there's a video about Eulerian network. Can you find that? Eulerian network. So this is theory, okay? But how are you going to make the real world into Eulerian network? Because Eulerian network apparently one of the best network, yeah, in terms of grid system. Okay. And if you can make, look at this. This is also very interesting. Yeah? What will happen, okay, if your network actually pre-magic? What will happen if your capacity is actually pre-magic? Your G, your congestion level, will be exactly all the same for entire network. You try. Yeah. What will happen if your capacity is actually pre-magic? What will happen if your number of lanes is actually pre-magic? You understand pre-magic, right? The sum of row equal to the sum of columns. Okay. So this is a simple challenge, no? Then suddenly you can start to see, oh, the entire congestion, okay, all the same numbers. So if you set 0.9, then the entire network becomes 0.9. This is the ideal of the ideal. Interesting. There are many open problems, okay, that probably I also don't know. Okay, so please do some research. You have the tools already. So all you need to do is play. Right? Okay. Next problem, for example, what will happen if you change, for example, I have certain policy. Okay? For example, I want to increase the number of lanes. When it is congested, and then I will increase the number of lanes. When it is the most congested part, I will increase again. Okay? Road widening all the time. Okay, what will happen to the long-term effect? Oh, you can play that, right? Isn't that? Oh, question again, for example, what will happen if instead of road widening, is it possible if I actually reduce the number of lanes? Will actually improve or not? So you have the tool, so all you need to do is just change in the Excel, right? Oh, I hope this is interesting enough. There are a lot of challenges that you can challenge yourself using this tool. Okay? Any creative idea that you can start to see, you can develop, you can create thousands of papers actually using this, isn't it? Huh? Remember that textbook topology now matters. This is the supply side, no? That you can connect to the demand side. Okay. So this is interesting research work that you can keep developing. Okay. So these are the few things that I can point out, but probably you can discover something better than that. Okay. Oh, for example, okay, or say this is certain, say during Holy Weeks, example, yeah. So certain roads are blocked, right, for procession, right? Or what will happen if I close that road? Okay? That means the link temporarily disabled. Okay, then you can start to see, oh, which link is actually now become more congested? Is it enough or not? Okay, and then can I change that? Okay, now I can change the direction of the road so that the rerouting will be much better. This kind of things you can do, no? Not necessarily you do only road widening, isn't it? So that is uncreative at all. Okay, road widening is not creative at all. So do something, a lot of things within using this model. Okay, you can practically do a lot of things. Yes, of course. In rerouting, you can choose, right? Remember, in there you can see the shortest path. You can also find all the path, you know, in the web a while ago. There are tools there. Okay, you can. All the tools is there, so all you need to do is just to use. Okay, you can use the rerouting. Okay. Okay. I hope this is useful enough for you. So give me feedback. Come on. Don't hesitate. Any critique is also okay, you know. The rest that is quiet. This is really you understand or you don't. So in the assignment for today and next 2 weeks, okay, all you need to do is create a simple, maybe 4 or 5, yeah, maybe 6, 7 links, right? Then you create, yeah, the same as the practice one, okay? So you set the total flow, okay? And can you get the cardinal network? Yeah, that's the minimum integer flow. Okay. And then you put what is the total flow. Okay. And then you do a scaling. Okay. Can you do scaling, for example, calculate based on average flow, standard deviation of flow, and then can you also calculate the coefficient variation of flow? Okay. So this is another little research. No? Can you conclude the invariance? The invariance means don't change. Okay. The flow changes, okay, but there is something not changed. What is that? That's the puzzle. Yeah, do a little research. Okay. IFN can be scaled up and down. Okay. They are equivalent. Why they are equivalent? Because the stochastic flow, the stochastic matrix does not change. Okay. When we said equivalent, that means the stochastic matrix does not change. Okay. Do you understand the meaning of stochastic matrix there? Stochastic matrix means the probability, okay, that the flow will turn left, right, or straight in its intersection, right? So what's the meaning of the stochastic matrix does not change? That means the habit is there, right? So once you put there, usually you will use in that intersection, usually you turn right to go, isn't it? Or usually you turn left in going. So the habit is already there. That's the meaning, right? So, oh, but people change habit, yes, but minor. Okay, everyone is usually do the same things. That's the assumption there that we put. Okay. Okay. That also means, okay, ceteris paribus in economic, that there is no change within that year. Right. So, but if you change structurally, for example, oh, now the traffic signal change. Okay. For example, the green time in the traffic signal change. The green time compared to the overall cycle time, that is stochastic matrix. Right? Because you allow how many seconds to go to the right, to the left, and right. That is exactly the stochastic matrix that you set. So stochastic matrix can be set, or can be assumed, or can be observed. Now, depending on what the case that you are doing. Any debate, question, critics? Come on. Okay, tell me what do you get, so that I can you give me confirmation what you actually learned today? Anyone? Correctness, are you still there? Vin, on. Vin Santos.
Yeah. Aside from using the tools for IFN, sir, we appreciate some of the linear algebra concepts that you introduced.
Oh, I did not.
Especially
Later we will do that, huh?
Yes, sir. The pre-magic thing.
Oh, okay. That's
a
only
new concept for
definition.
me.
Okay, next time we will do the real linear algebra in Excel, okay?
Okay. But much more important is maybe everybody else is also absorbing the new concepts, especially on each matrices, what it means, and if you held something constant along that matrix, then what happens if you plug and play from that matrix? Yeah, we need more readings and more examples later.
Okay. I have written like almost 500 pages ideal flow network books. I don't know if you have time to read, so, but if you really want, I can share with you, but if not, so. That's
Yeah,
that's
sir.
no
If you
point. Eh?
if you can also share in Moodle, sir.
Oh, okay, I can share, no problem, okay. So, but that's not only IFN for transport, yeah, that's complete for example, for ecology, for AI, and so on, so that's different field.
Yes, sir. And you pick my curiosity on the use
Yeah,
of
yeah, if you
changing
want
the
to use that
stochastic
for,
on green time, cycle times of traffic signals.
oh, that is simple. Look at this, green time divided by the total cycle time, that is actually the outflow, isn't it?
Yeah, yeah.
That's exactly stochastic metric, isn't it?
So it's actually the probability of allotting the go
Yes.
time stop time.
Yes, so in intersection that you have the traffic signal, the stochastic matrix now depends on the length of the number of lanes. Now depends on the traffic signal timing.
Yeah.
Okay. Now you can also now based on that concept now you can change. Oh, in that case, if the number of lane is bigger, okay, the green time should be proportion of that, isn't it? Okay. If that is not proportion, something is wrong with the green time also. Right? Supposed to be. Based on the same logic.
Okay, sir. I'm still processing it, absorbing it.
Processing it.
Also, one thing I'm curious about is the effects of laybys in intersections. How do you
Lay-by?
model it using the IFN?
What is lay-by?
You're providing additional lanes for turning movements, for example.
Ah, okay, okay. So the road widening near the intersection, that is
Yes.
not counted. That is only for local, so that the movement is
Yes, yeah.
yeah. That
So
is not
dedicated right turning
correct,
or
correct, correct.
turning way.
That is not counted, yeah. Yeah. Well, if you want to count the detail using the geometric design, okay, the turning radius and so on, then you go to microscopic, not using IF.
Okay.
In
We're dealing with the macro for IFN.
okay, you are doing it macro, so that means the whole section of the link, no?
Yes, yes.
So the one that you tell is actually microscopic. That means you need to do the car following model.
Okay.
The animation. Okay. That's dealing with the geometric design, with the acceleration lane, deceleration lane, and so on. Okay.
Okay, thank you, sir.
Thank
If
you,
I
thank
have
you.
any questions, I'll
Go.
later on.
Yeah. Anytime. Okay.
Thank you, sir.
Yeah. Thank you. June, you want to say something?
Ay, sorry, sir. We appreciate the file that you shared a while ago, the Excel
Okay.
file. So may I just request that every time we discuss new methods or formula, we can have the same sample on how
No
it is.
problem. You need just to request. If you don't request, I don't give, right? Okay. If you
Yes, sir.
request it, of course I will give you.
So we can follow it easily. Thank
Right. So
you.
it's glad that Glenn was asking. Thank you. Okay. Good. Any other feedback? So this is clear. With this, you can do your project also, right? Challenge yourself, okay? So that you will feel good about yourself. So when are you going to present? 27, is it okay? The idea of your group projects, maybe just 5 minutes. What do you want to do? So that you have some kind of direction. 27, is that okay? 2 weeks from now. Okay. Just a few slides, maybe 5 slides like okay. Per group. Okay. Good. So thank you very much then. So for today. Okay, so next week, or if you have you can follow me in YouTube, in Telegrams. Okay, so next week let's discuss about transport supply. Okay, so we will go deeper about network representation. Okay, and there is a lab there, network and matrix. And then there's a video there, network structure, utilization. Yeah, you can watch first before so that you can understand. Okay, and then we will do the lab on network structure and utilization. Okay, and up to pedestrian mean business. And then next week you will have that assignment, network structure and utilization. Okay, good. So thank you very much for today. In that case, if you have any other things, we still have 3 minutes if you want. Or we just dismiss.
Sir, I have a question.
Okay, cool.
I might have missed it from the discussion, but apart from doing trial and or calibration, how do we get the optimal level considering all parameters, or is the discussion part of the Nash equilibrium or Pareto optimal discussion, or are the results already showing the optimal level, sir?
No, the result is not optimal level. So if you want to do optimal level, you need to do a discrete combinatoric. Okay, that is exactly the advantage of having open source. Can you see that? Because now you have open source, that means the code is with you. Then you can do optimization of whatever you want. That is in Python. All right. So to say you use a different combinatoric. I have one check-in model. Okay. There is one slide, one video. Okay. What is the title? Let me find. There is one video. Here. Automatic generation policies of alternative traffic solution for traffic congestion. Okay, almost the end. There's one video about that. This one. Yeah. So in this video, you can see, and this is very good question mark. Okay, start to distinguish, okay, all the possible atomic policies. Okay, so I identify atomic policies. Okay, for example, add links. Okay, add lane, reduce lane, remove link, and then change the direction. Okay. Actually, there are 3 more, but anyway. So based on this atomic, you can combine. Okay, now become molecule, like in chemistry, right? And then from there, you can do a combinatoric optimization. And then a lot of way to do. For example, genetic algorithm, you can use dynamic programming and so on. There are many methods to do that combinatoric optimization. Okay? To get for your network, which one is the best? So, and I have the lab also there. Okay, next time we will discuss that you can for small network. Okay, we can do a combination, and then you can search which one is actually the best. Okay. Okay. The one that you put in there is not yet optimal, of course.
Okay, sir. So basically what we're doing is we're just trying to see if the decisions we make satisfy the Markov stochastic matrix.
At that time, that is the correct. So the decision that you make is satisfy that Markov matrix. Okay, that is the IFN. Okay, but that is not the optimum one. That is the equilibrium. Equilibrium means, you know, it's hanging like this. Okay, that means if you go to the left a little bit, it will fall down. Yeah. Okay, a little bit to the right, it will fall down also. So exactly hanging. Okay, the exact point where it is balanced. Okay. So of course, this theory I understand, but look at this. Queuing theory has been with us like since 1905, right? So now it's 2002, so more than 100 years. Okay, right? So, and you're using it anyway. Newton law, you also use it anyway. It's based on the same ideal condition. So now we are approaching with the same technique, yeah, of approach. Okay, so using steady state solution. Okay, so if you can accept queuing theory, why you cannot accept ideal flow? That's my question. Right.
Okay, sir. Thank you, sir.
Yeah, thank you, thank you. You're very smart. That kind of question. Okay, so past the time. So thank you very much. Okay, so see you next week on time. Do the assignment for next week, and today you have an assignment for next 2 weeks. Finding the invariance. Okay, good. Thank you.